In the spring of 1927, in the subterranean vaults beneath Canterbury Cathedral, a stonemason named Arthur Wickham was repairing structural damage from winter frost when he discovered something that contradicted everything the architectural records claimed about the bell crypt's purpose. The chamber, officially designated as storage space for the cathedral's 12 massive bronze bells when they were lowered for maintenance, extended far beyond what those dimensions required. Wickham's measurements, recorded in his repair log, showed the crypt measuring 43 meters in length, 18 meters in width, with a vaulted ceiling reaching 9 meters at its apex. The cathedral's bells, even when all 12 were lowered simultaneously, an event that had never occurred in documented history, would occupy less than a quarter of that volume. More troubling were the architectural features Wickham documented but could not explain. The crypt's walls contained a series of precisely carved niches, each approximately 60 centimeters deep and spaced at intervals of 1.618 meters, the golden ratio. The niches were not rough storage alcoves, but carefully finished chambers with curved backs that created subtle acoustic properties when Wickham tapped them with his tools. Each niche resonated at a different pitch, forming what appeared to be a chromatic scale across the length of the chamber. The ceiling vault was not a simple arch, but a complex geometry of intersecting ribs that converged at specific points marked with carved stones, each stone showing subtle wear patterns suggesting something had once been mounted there, then removed. Wickham's report, filed with the cathedral's Works Department in May 1927, noted these anomalies and requested clarification from the architectural records. The response, dated June 1927, stated that the niches were decorative elements typical of the period, and the ceiling mountings had held liturgical fixtures, purpose now unknown. The explanation satisfied administrative requirements. The report was archived. Wickham continued his repairs, working in a space that seemed designed for something far more complex than storing bells. The official history of cathedral bell crypts is straightforward. Medieval and Gothic cathedrals housed massive bells in towers, suspended by elaborate timber frameworks. When bells required maintenance, recasting, or replacement, they were lowered through hatches into underground chambers where the delicate work could proceed protected from weather. The crypts provided workspace, storage, and, in some cases, foundries where bells could be cast in situ, avoiding the dangerous process of transporting multi-ton bronze castings through narrow medieval streets. This explanation appears in architectural histories, cathedral guidebooks, and ecclesiastical records. It is logical, practical, and documented. Yet scattered across Europe, from Canterbury to Cologne, from Chartres to Santiago de Compostela, cathedral bell crypts exist with features that exceed any practical requirement for bell storage or maintenance, chambers extending hundreds of meters beyond necessary dimensions. Elaborate acoustic geometries serving no apparent purpose if the space is meant merely to house inert bronze masses. Ventilation systems far more sophisticated than needed for occasional metalwork. And in some cases, physical evidence of technologies that should not have existed when the crypts were constructed. On August 14, 1883, in Cologne, a German acoustician named Hermann Klein was hired by the cathedral chapter to investigate persistent low-frequency vibrations affecting the structure. The cathedral's massive bell, Kaiserglock, had been installed in 1875, and since then, clergy and visitors had reported feeling subtle tremors during and after bell ringings, vibrations that seemed to persist long after the bell's physical oscillation had ceased. Klein brought specialized equipment, tuning forks calibrated to specific frequencies, resonance tubes, and a primitive oscillograph capable of recording sustained vibrations. His investigation led him to the bell crypt, a vast chamber beneath the cathedral's south tower. The official records described it as constructed in 1842 during restoration work, following damage from the Napoleonic Wars. Yet Klein's examination revealed architectural features inconsistent with 19th century construction. The chamber's walls showed tooling marks, suggesting medieval masonry techniques. More significantly, he discovered a network of channels carved into the walls and a floor, each channel precisely dimensioned and positioned to create acoustic pathways. When Klein introduced sustained tones into the crypt using an organ pipe, the channels amplified specific frequencies while dampening others, creating interference patterns he could measure with his equipment. Klein's report, submitted to the cathedral chapter in November 1883, described the crypt as an acoustic mechanism of considerable sophistication, designed to capture and manipulate sound waves in ways that suggest purposes beyond simple bell storage. He noted that the chamber's dimensions created standing waves at frequencies corresponding to the cathedral's bells, and that the carved channels seemed designed to direct these acoustic energies to specific locations within the cathedral structure above. His conclusion was cautious but clear. The crypt functions as a resonance chamber, though for what ultimate purpose, I cannot definitively state. The cathedral chapter received Klein's report, but took no action on his findings. The report was filed in the cathedral archives, where it remained until it was digitized in 2004. Klein published a brief academic paper on his measurements in 1884, focusing on the technical acoustic properties without speculating about purpose. The paper appeared in a specialized German physics journal and was cited occasionally over the following decades, but never prompted broader investigation into cathedral bell crypts as acoustic technologies. In 1906, in Paris, during excavations for the metro system, workers digging beneath Notre-Dame encountered an anomaly that forced a temporary halt to construction. Approximately 15 meters below the cathedral's floor level, the excavation broke into a chamber that architectural records insisted should not exist. The chamber, roughly circular and approximately 20 meters in diameter, had walls of dressed limestone and a domed ceiling with acoustic ribs similar to those in the cathedral's famous vaults above. But this chamber was not connected to any documented part of Notre-Dame's foundation or crypt system. It existed in isolation, accessed only by a narrow spiral staircase that had been filled with rubble at some point in the past. The French engineer overseeing the excavation, Philippe Marchand, documented the discovery and reported it to the cathedral authorities. A brief investigation was conducted. The chamber was determined to be a previously unknown foundation work, likely abandoned during medieval construction. No artifacts were found inside. The chamber's walls showed no soot from torches or candles, suggesting it had never been used for any practical purpose. The decision was made to seal the chamber and route the metro tunnel around it rather than risk destabilizing the cathedral foundations. Marchand's report, preserved in the Paris Municipal Archives, includes detailed measurements and photographs of the chamber, but offers no explanation for why such a sophisticated space would be constructed and then apparently never used. Yet oral histories from Notre-Dame's bell ringers, collected by a French folklorist in 1898, include references to les chambres du son, the sound chambers, beneath the cathedral. The bell ringers describe these as spaces where novices were sometimes taken to experience the cathedral's living voice, a phenomenon where the stone itself seemed to produce sustained tones in response to the bells above. The folklore was dismissed as superstition, the poetic language of craftsmen describing ordinary acoustic echoes. But the timing is notable. The folklore was collected 8 years before the chamber was discovered, described by bell ringers who could not have known it existed, yet who accurately characterized its acoustic properties. On March 22, 1934, in Chartres, France, a renovation crew working on the cathedral's crypt made a discovery that would remain classified in church records for decades. While reinforcing a wall damaged by groundwater seepage, workers found a sealed chamber behind a section of medieval masonry. The chamber, approximately 4 meters square, contained objects that seemed impossible, a series of bronze spheres of varying sizes, each hollow and precisely tuned to specific pitches. The spheres ranged from 10 centimeters to nearly a meter in diameter. Each was suspended from the ceiling by bronze chains, positioned at specific heights that created a three-dimensional geometric pattern. The cathedral architect who examined the find, Jean-Baptiste Fourier, no relation to the mathematician, recognized the spheres as Helmholtz resonators, devices designed to amplify specific acoustic frequencies. But Helmholtz resonators were not invented until the 1850s by German physicist Hermann von Helmholtz, more than 6 centuries after Chartres Cathedral was constructed. The medieval builders who created the chamber could not have known the principles of acoustic resonance that Helmholtz would later formalize. Yet here were precisely engineered resonators, carefully tuned and positioned, hidden in a sealed chamber beneath one of the Gothic era's greatest architectural achievements. Fourier's report to the church authorities recommended preserving the chamber and its contents for study. Instead, the bronze spheres were removed and melted down in 1936. The official explanation cited the need for bronze for church renovations. Fourier's photographs and measurements survived in his private papers, donated to the Bibliothèque nationale de France after his death in 1958. By then, the physical evidence was gone. Only the documentation remained, showing devices that should not have existed, designed according to principles that should not have been known, serving purposes that were never recorded. The pattern repeats across medieval cathedrals with bell crypts, chambers with acoustic properties far exceeding what bell storage would require, architectural features suggesting deliberate manipulation of sound waves, physical evidence of technologies that predated their supposed invention by centuries, and in every case, discoveries that were documented, briefly investigated, and then effectively forgotten, explained away as decorative features, abandoned experiments, or misidentified objects. In 1952, in Wells Cathedral in England, an electrical engineer named Robert Thornton was installing new lighting in the bell tower when he noticed copper conductors embedded in the stonework of the crypt below. The conductors, oxidized green with age, ran in precise patterns along the walls and connected at points that corresponded to the positions of resonant niches similar to those Wickham had documented at Canterbury. Thornton, curious about their purpose, tested them for continuity and found several were still intact, forming circuits that terminated at a central point in the crypt's floor. Thornton's report to the cathedral verger suggested the conductors might be remnants of an early lightning protection system, but the configuration was wrong for lightning protection. The conductors led down into the earth rather than up to grounding points, and the dating was problematic. The stonework containing the conductors showed tooling consistent with the cathedral's original 13th century construction, while systematic lightning protection wasn't widely implemented in Britain until the late 18th century after Benjamin Franklin's experiments. The cathedral dean, reviewing Thornton's findings, noted that similar copperwork had been discovered during renovations in 1887 and attributed to medieval plumbing or heating systems. Yet Wells Cathedral had no documented heating system beyond fireplaces until the 20th century, and the conductors' routing bore no relationship to water supply or drainage. Thornton's suggestion that the conductors might have served some electromagnetic purpose was politely dismissed. Medieval builders, the dean pointed out, had no understanding of electricity. The conductors were likely decorative or served some mundane function now forgotten. The conversation ended. The conductors remained embedded in the stone, their purpose officially unexplained. By the 1960s, a small number of researchers, primarily acousticians, architectural historians, and physicists with interests in historical technology, had begun to notice the accumulated anomalies surrounding cathedral bell crypts. Each individual discovery could be explained away as an outlier, a misidentification, or a decorative flourish. But, viewed collectively, the features suggested something systematic. Cathedral bell crypts had been designed as sophisticated acoustic devices, possibly for purposes beyond anything acknowledged in ecclesiastical or architectural records. In 1967, a symposium on medieval acoustics held at the University of Cambridge brought together researchers who had studied various aspects of cathedral design. A paper presented by acoustician Margaret Hartley examined resonance chambers in 6 English cathedrals, documenting consistent geometric ratios, similar acoustic properties, and architectural features that seemed designed to capture, amplify, and direct specific sound frequencies. Hartley's conclusion was carefully worded. The consistency of design suggests shared knowledge of acoustic principles among medieval builders, applied with precision that implies specific intended functions, the nature of which remains to be determined. The paper generated brief discussion, but no follow-up research was funded. The symposium proceedings were published in a limited circulation academic journal and promptly forgotten. Hartley continued her work independently, eventually publishing a book in 1983 titled Gothic Acoustics: The Hidden Science of Cathedral Design. The book documented acoustic anomalies across dozens of European cathedrals, but offered no unified theory of purpose. It sold modestly among architectural historians and went out of print within 2 years. On September 11, 2001, In the aftermath of the World Trade Center attacks, structural engineers examining ways to protect historic buildings from catastrophic resonance damage revisited medieval cathedral construction techniques. Modern skyscrapers use tuned mass dampers, heavy weights suspended in the building's upper floors that move in opposition to the building's shear, dampening dangerous oscillations. The principle seemed to echo something about cathedral bell crypts, massive bronze objects, bells, suspended in chambers with specific acoustic properties. Could the crypts have functioned as primitive tuned mass dampers, protecting cathedral structures from earthquake or wind-induced resonance? A 2003 study by MIT structural engineers tested this hypothesis using computer models of medieval cathedrals. The results were intriguing but inconclusive. The bell crypts did create damping effects, but only when bells were actually suspended in them, which occurred rarely, as bells typically remained in towers. More significantly, the crypt's acoustic features seemed over-engineered for simple structural damping. The carved niches, the geometric positioning of architectural elements, the elaborate acoustic pathways, all exceeded what would be needed for vibration control. If the crypts were dampers, they were dampers designed to do something more. In 2011, in Strasbourg Cathedral, renovation work in the crypt revealed something that had been hidden for centuries. Behind a section of wall, added during 17th century modifications, workers found the original medieval wall intact, and carved into that wall, at precise intervals, were mathematical notations. Not the Roman numerals typical of medieval construction marks, but mathematical formulas rendered in a symbolic notation that would not be standardized until the Renaissance. The formulas described wave mechanics, resonance frequencies, and harmonic relationships. They were equations for calculating acoustic properties. The discovery was documented, photographed, and submitted to the cathedral foundation. Mathematical historians examined the photographs and confirmed that the notation style matched late medieval mathematical manuscripts, but applied to concepts that wouldn't be formally developed for another 3 centuries. The foundation's official response noted the find as an interesting example of medieval mathematical practice, and filed it with other architectural curiosities. The wall was resealed behind new plaster. The formulas are preserved only in photographs, their purpose and origin unexplained. Today, cathedral bell crypts function primarily as tourist attractions and atmospheric venues for concerts that exploit their renowned acoustic properties. Visitors descend stone stairs into chambers where medieval bells once hung, where acoustic resonance creates the illusion that music lingers in the air long after instruments have stopped playing. Tour guides explain that the crypts were built to store bells during maintenance, that their excellent acoustics are a happy accident of medieval construction, that any unusual features are decorative elements from a time when craftsmanship valued beauty over pure function. But the evidence waits in archives, in photographs, in measurements and reports filed away over more than a century, chambers extending far beyond practical needs, acoustic features of impossible sophistication, technologies that shouldn't exist, mathematical notations describing principles that wouldn't be formalized for generations, copper conductors leading nowhere official history acknowledges, bronze resonators tuned to frequencies that medieval builders supposedly couldn't calculate. In 2019, in Canterbury, renovation work on the very crypt where Arthur Wickham made his observations in 1927 encountered something new. Ground-penetrating radar, used to assess the stability of the foundation beneath the chamber, revealed additional spaces below the known crypt, chambers at least 2 levels deep, each with geometric regularities suggesting deliberate construction. The deepest detected chamber lies approximately 30 meters beneath the cathedral floor. Its purpose is unknown. Its access point has never been found. It exists on radar scans and in geological surveys, a structured void where official history insists only earth and foundation stone should be. The pattern persists, buried in stone and sealed behind walls and archived in reports that few will read. If bell crypts were designed merely to house bronze bells awaiting repair, they represent engineering far in excess of function. If they serve some other purpose, acoustic, electromagnetic, structural, or something else entirely, that purpose was never officially recorded, or the records have been lost. Or the records remain classified in archives that guard secrets older than the official histories acknowledge. The bells still ring in cathedral towers across Europe. Their sound cascades down through stone and timber, penetrating the crypts below, where geometric spaces wait with their carved niches and acoustic channels, their embedded conductors and sealed chambers, their mathematical formulas describing waves and resonance. The spaces function as they were designed, though for what ultimate purpose, the official records refuse to say.